Video is about how to find different frequency distributions from data. So first off, the definition, frequency distribution. It shows how data are partitioned among several categories or classes by listing the categories along with the number or frequency of data values in each of them. So here are the instructions on how to create a frequency distribution. So we're going to select first the number of classes. Usually we want that to be between 5 and 20. And then we need to calculate the class width. And we want to round the result so that we get a nice number. Usually we round this up. So the class width is equal to the maximum data value minus the minimum data value divided by however many classes you want to have. Choose the value for the lower class limit by either using the minimum number in your data set or a nice number that's below the minimum. List all of your lower class limits and then list all of your upper class limits, and then we're going to tally up the frequencies of each class. So there's a step-by-step directions on how to create a frequency distribution. So now we're going to do this for this example. So this is some actual data of a midterm in one of my online classes. And so we're going to create a frequency distribution for this data. And so the first thing that I like to do, only because it makes getting the frequencies a little bit easier, is ordering the data from the smallest value up to the largest value. So looking at this table, 64 is our smallest. And the next one after that is 80. And then the next one after 80 is the 85. And then the next one after that is 94. And then after that, 104. And notice I'm crossing these off as I list them. It helps me make sure that I've used all of my data so that I don't forget any, and I also don't repeat any data values, so I don't list them twice. So after 104 we have 105, and then we have 109, and then we have 112, and then we have two 113s, and then we have two 120s, and then after 120 the next one would be 123, and after 123 we have 126, oops, and finally we have the last one, 128. So there's our ordered data, and so now we can very clearly see the smallest value and very clearly see the maximum value. So we're going to do 5 classes. And so we want to calculate our class width. And so that's going to be our max minus our min divided by the number of classes. So our maximum data value was 128. Our minimum data value is 164. And then we want to divide that by 5. So when we do this calculation, 128 minus 64 gives us 64, and then divide that by 5. That gives me 12.8. We want to round this up to a nice number. So we're going to use 15 for our class width. Okay, and then when you're creating this, you also, like 64 is not a very nice number, so I would say start at 60 instead. So we're going to start this off at 60. And these are midterm scores. And so we have one column for the midterm scores and then another column for their frequencies. So I'm going to start this off at 60. And our class width is 15. So this is going to be our lower class limit. And so I'm going to list all of those first, and then we'll list the upper class limit. So just add 15 to this. That gives you 75. And then add 15 to 75, and that gives you 90. Add 15 to 90, and we get 105. Add 15 to 105, and we get 120. So now I have 5 lower class limits. And now I want to list the upper class limits. So the upper class limit is going to be one less than this lower class limit. So it's going to go from 60 to 74, and then from 74 to 89, and then from 90 to 104, and then from 104 to, or 105, sorry, to 119. And then here, it's going to be one, so we would have added 15 to get this lower class limit. So to get this upper class limit, you can either add 15 to 119 or 14 to 120. So that would be 134, because our next lower class limit would be 135. So these are our upper class limits. And now we calculate the frequencies and put those in our table. So, and the nice thing also about having your ordered data is that it makes counting the frequencies easier as well. So anything below 74 and below is going to be in the first class, and so that's just the first data point, so just 1. And then everything from this mark up to 89, so up to right there. So that's 2 data values in that class. And then from 90 up to 104, so that cutoff would be right there. So there's 2 data values in there. And then from 105 to 119, so up to right there. And there are 5 data values in that class. And then the rest of the data is between 120 and 134. And there are 5 data values there as well. So another little quick check that you can do is add up your frequencies, and that should equal the total number of data that you started with. So we started with 15 data values, and so if we add these up, 1 plus 2 plus 2 is 5, and then 10 more gives us a total of 15. One other thing that you need for these is called the class boundaries. The class boundaries is the midpoint between this upper class limit and this lower class limit. And there's also a boundary right here and a boundary value at the top. So first I would calculate this one, so it's the midway point, and to find the midway point you would just find their average. So add them together and divide by 2, or it's halfway between, which is easy when they're nice whole numbers like this. So halfway between 74 and 75 is 74.5. So now I know that it's 0.5, so it'll be one less than this, 0.5. So the one before 60 would be 59.5. And then you just keep on finding those midway points between the upper class limit and the lower class limit. So we have this one. Now we need to get this one. So that's going to be 89.5. The next one will be halfway between here, so 104.5. And then halfway between here, so 119.5. And now we need to go on the top end, so that would be 134.5. So that is the list of our class boundaries. So this one was pretty easy because they're whole numbers. If they're not whole numbers, say we had a lower class limit of 0.12 and the next upper class limit of 0.13, for instance. So how would you know where the boundary point was between these two? And so you would add them together, 0.12 plus 0.13, and divide that by 2. So let's do that. 0.12 plus 0.13, we get 0.25, divide that by 2, and we get 0.125. Okay, so that's how you would find the class boundary between those two. And then to find the one that would come before this one, so let's say that this was the first lower boundary or lower class limit, you would just add on. So we had to add on 0.005, so you would subtract 0.005 from this to get the other one, right? So if we took 0.125 minus this lower class limit, 0.12, we would get 0.005. So this is what you would have to add to the 0. Or subtract, sorry, to the 0.12. So if we do that, we would get 0.115. So this would be the other boundary point, the boundary point before this one. And then this boundary was the 0.125. Okay, so just in case you run into some numbers that aren't nice, pretty ones like we had in our example. So the boundary points, you always want to make sure that those are values that are for sure not going to show up in your data. So that's the key about the boundary points. The lower class limit and the upper class limits can be data values, and most likely will be, but the boundary points values for sure, you do not want those to be values that can show up in your data. So they should go one decimal place beyond what your data has in it. So the next type of frequency distribution that we're going to look at is a relative frequency distribution. Okay, so we're going to take the last example and we're going to turn that into a relative frequency distribution or a percentage frequency distribution. So those are just slightly different names that mean the same thing. And so instead of listing frequencies, we're going to list percentages. So 1 is what percent of our total number of data values. So that would be 1 divided by 15. And so we're just going to copy this down. Whoops, I don't need a dash there. And here we want to have listed relative frequency. So our lower and upper class limits will be the same. So 60 to 74, and then 75 to 89, and then 90 to 104, and then 105 to 119, and finally 120 up to 134. So now, in order to calculate the percentage that we're going to put here, we just take this frequency and divide it by the total number of data that we started with. So we're going to have 1 divided by 15. that gives me 0.0666, and then eventually a 7. So to convert this decimal to a percentage, we're going to move our decimal 2 positions to the right. And so this would be 6.67%. And then 2 would be 2 divided by 15. And that gives us 0.1333, and the 3 repeats. So again, move our decimal 2 positions to the right, so that would be 13.33%. And then we have another 2, so that's not going to change, 13.33%. And then the last value we had in our frequency table was 5. So 5 divided by 15 gives us 0.333 repeating, and so again move our decimal 2 positions to the right, and so we would have 33.33%. And the last 2 were both 5, so that's not going to change that percentage. And so now with this frequency distribution, when we add this up, it gives us 15, the total number of data. When we add this up, it should give you 100%. So let's see what we get when we add those up. 6.67 plus 13.33 plus another 13.33 plus 33.33 plus another 33.33. And when I add that up, I get 99.99. And this is okay. So the reason that this happened is because of our rounding. So there's a little bit of error in there because of all the rounding that we had to do. And that's okay. We can be okay with 99.99%. So that is a relative frequency distribution. And so I would start off, if I had to do a relative frequency distribution, I would start by getting the frequency distribution first and then converting that to a relative frequency distribution. Again, the boundary values will be the same for this as they were for just our regular frequency distribution. So now on to a cumulative frequency distribution. So again, for this one, we are going to use the same example. So I'm just going to get that frequency distribution here. So there we have it. And so this is just when you get to the very bottom, this bottom frequency should be the total number of data that we have in our data set. So we want our midterm scores again. And here we want cumulative frequency. And so now, when we're writing in these midterm scores, what we want for our classes is we want less than 75 for the first one, and then less than 90, and then less than 105. Next, it would be less than 120. And the last one would be less than 135. Remember, 135 would be the next lower class limit, even though it's not listed there. So now the number of data values that are less than, strictly less than 75, not including 75. So it's just the data values that were in our first class here. So that would just be 1. And now we want, in this line, we want all of the data values that are less than 90. So that's these 2. So that would be 1 and 2, so that's a total of 3. And then we want all of the data values that are less than 105. So that's, whoops, I erased one. So that would be all of these. So 2, 2, and 1, so that's a total of 5. And for 120, we want all of the data values that are less than 120. So that's all of these first four. And so that's 5 plus 5, that gives me 10. And then less than 135 would be all of the data. So that would be the 15, the total. So again, you should be starting with whatever was in your first class, 1, and it should gradually work its way up to the total number of data values that you had to begin with. And so that is it for frequency distributions. Let me know if you have any questions, and I hope you're having a wonderful day. Thanks.